Hello, everyone. Welcome to our week 3 Q-Learning Survey Project update number 2. And this week, we are focusing on modern Q-Learning, benchmark rigor, and verification. And this is a Learning First research collaboration. This meeting had 3 people present live, but the lower attendance was mostly scheduling rather than disengagement. One person had Wi-Fi problems, Charles was meeting with his professor, and another contributor was traveling. We still have 6 active contributors, which is a healthy core for a volunteer learning-focused project. The important point is that the project is moving forward even when not everyone can attend every meeting. Our standard remains learning first, discussion before rushed conclusions, and verification before claims enter the manuscript. A major focus this week was turning modern Q-learning into something more concrete. We identified 4 deployment regimes where the original DQL on Atari framing is no longer enough, such as offline learning, language models, multi-agent system, and continuous control. Each regime creates a new weakness for Q-learning. For example, offline RL introduces distribution shift, LLMs introduce huge token action spaces, multi-agent RL introduces non-stationarity, and continuous control makes the argmax operation difficult. Our goal is to organize the papers not by name, but by the new problem they solve and the trade-off they introduce. And this is an early version of our modern Q-learning map. It is not another method genealogy. Instead, it traces a different story. A deployment setting creates a new technical challenge, and Q-learning methods introduce mechanism families to address it. For example, offline IL leads to policy constraints, conservative value learning, and implicit value learning. Continuous control leads to continuous Q functions, discretization, search, and auto-regressive action reconstruction. We will refine the labels and add more methods, but the basic structure is now visible. Continuous control became one of the clearest examples of how a simple Q-learning idea can branch into very different engineering solutions. For example, NAF makes the maximizing action analytically available by restricting Q values to a quadratic form. FSQ replaces continuous action with small directional updates. QTOBT keeps a flexible Q function but uses the cross-entropy method to search over actions. Q transformer creates an action one dimension at a time. And finally, EXPO-FT, instead of searching the full continuous action space, it uses a fine-tune a pre-trained VLA and proposes temporarily extended action chunks. A lightweight AD policy creates bounded residual corrections, and Q function selects the highest value original or edited candidate. These approaches look different, but they all answer the same question: how can we approximately maximize Q over a continuous action space without making the algorithm unstable? And next, we look at the benchmark. Another major contribution this week came from the benchmark analysis track. The question is not simply whether Atari scores are useful. Atari remains historically important and should always stay in the survey. The question is whether a number extracted from one paper is directly comparable to a number from another paper. Often it is not, because training budgets, random seeds, evaluation protocols, and environment settings can differ. Our benchmark priority should therefore be transparency before leaderboard building. First show the experimental context, then report uncertainty where available, and only then make comparative claims. And here, we are looking at the benchmark coverage heat map an example. A coverage map heat map should complement the Atari tables really well. Rather than forcing every Q-learning method into one giant leaderboard, we can show which method families have actually been evaluated on which benchmark ecosystems. Classical DQ variants are often evaluated on Atari, while offline methods are often concentrated on D4IL. Multi-agent methods appear in SMAC. Robotics and continuous control appear in Mujoko, IR bench, and related settings. And finally, language-focused Q-learning has its own text or dialogue benchmarks. And this fragmented coverage is not just a visualization detail, it is a real survey insight. Evidence for different modern Q-learning branches often comes from separate evaluation cultures. And now, a verification ledger. ELP created something especially valuable this week, a claims verification ledger for the main draft. Instead of asking contributors to vaguely check the paper, the ledger separates claims into citations, numbers, experiments, time-sensitive repository facts, and our own synthesis claims. It has already surfaced inconsistent years, missing citations, arithmetic errors, and places where a strong interpretative statement needs better evidence. This gives Charles and the rest of the team a practical system for making the paper auditable. AI can help organize material, but a human needs to verify what ultimately enters the manuscript. Lastly, what is the next step? It is not to write a huge amount of new text immediately. For the modern Q&A track, we will refine the taxonomy, improve the diagram, and verify representative mechanisms. For the benchmark track, we will audit protocol metadata and prototype a coverage heat map. And the project is gradually becoming more than a survey paper. It is becoming a structured map of what QLearn can do, where each family is actually evaluated, and where the field still lacks evidence. Thanks for listening.